Hey, welcome back to Fat Mama Physics. This is part 3 of 4.1 inverse operations, kind of introduction to algebra. So in this video, like I said, I will be covering harder examples below. So again, it will be the similar format. I do one, you do one, I do one, you do one, etc. Okay, let's start with example 1. Okay, so, sorry, that's 10a. 10a, I have square root of x is equal to 5 over 4. Yeah, the other side is trickier because it's a fraction now. Whatever. We can deal with fractions, no problem. So let's zoom in. Okay, and we know the first step when we have a square root is we need to isolate for our variable. And to isolate for our variable, we need to apply the opposite operation. And for this first step over here, so that here we just have to take the square, and don't forget to bracket both sides of the equation. One thing I'm going to mention is because that right now we're only dealing with one step. When we go to 2 steps, we just other things will be involved. So just be very careful. Okay, taking the square here, these two cancel. I am left with x. The other side I have 5 over 4 squared. So don't forget, I am squaring the whole fraction. I'm not just squaring the 5 or just the 4. I'm squaring the whole thing. So if you think about it, this is kind of like 5 over 4 times 5 over 4, like that, okay? In other words, this is also similar to 5 squared over 4 squared. It's exactly the same thing. It's I'm taking this exponent and I'm distributing it to all the numbers that are inside my equation, like that, okay? So we know that 5 times 5, or 5 squared, is 25. We know that 4 times 4, or 4 squared, is 16. And that's our answer right there. Voila, okay? Okay, so, hey, what's the first one? Wasn't too bad, wasn't it? Okay, I'm going to get you to do E, all right? Not B, not C, not D, but E. Good time to pause the video. Okay, I will go over E with us together. So again, we have another square root to apply. We need to apply the opposite inverse operation, which is to square it. Now take a look at the other side. I have -5 on the other side. If I need to square the entire side, I have to make sure I encompass that negative sign as well. It's everything on the other side of the equation. This 2 and this square are this square, and the square root here cancel out. I am left with just x is equal to -5 squared. -5 squared is just -5 times -5. And we know that 5 times 5 is 25. And since I have two negatives multiplying each other, then I get a positive number for my final answer. So I get positive 25. You don't need that positive sign there. It's just to show you that it's a positive number. Okay, so that's it. That is for E. Okay. Next up, I am going to go over question B, okay? Now, question B, take a look. It's a square. So x is squared. To isolate for just the x, I have to get rid of the square. And the opposite operation for squaring something is to take the square root. So I'm going to take the square root on this side, imagining there's brackets. I have to do exactly the same to everything on the other side of the equation, including everything that's on top of the fraction, everything that's on the bottom of the fraction. So now I have the square here is going to cancel with my square root. I will just get x is equal to, okay, this is getting a little tricky on the other side. I'll probably do this. I'll take the square root, and here I have 9.8 squared over 16. And like I've just shown you before on this side, notice if I have, if I'm applying, say, an exponent, your radical sign is kind of like an exponent. You're not going to learn why in grade 9, but you just have to take my word for it, okay? To apply your radical sign to your entire fraction, you can think of it as like this. I need to apply my radical sign to my top number in my numerator, and as well as I need to apply the radical sign to my denominator as well. The other way you can think of it is you might think, oh my god, what are 2 fractions when they multiply each other is going to give me 9.8 to the power of 2 over 16. But I find this way a little bit easier to think about it, okay? So what do I get? I get x is equal to, hey, what's the square root of 9.8 squared? Hey, you've said it. Take a look. The square and the square root can cancel. So nice, right? So nice when things cancel out. Cancel out our problems in life. Imagine in real life. Haha. Sorry. So then you have the square root of 16. We know that square root of 16 is just 4. And there you go. This is our answer. You might be thinking, oh, hey, Miss Lee, do I need to convert this one to a proper fraction and get rid of the decimal? To be honest, if that is able to give us a decimal, that will probably be ideal. So we could try that. 9.8 divided by 4, we could actually just do 2.45. 2.45 is nicer, okay? If you were trying to work this out as a simplified fraction, we could do that. Let's see. 4 goes in there. Can't do that perfectly. Here, let's quickly work this out. Let me do it. Let's zoom in. Okay, let's zoom in, make this a little bit smaller. We have a little bit more space, hopefully. All right. Easiest way to get rid of that decimal is to multiply top and the bottom by 10, right? So that moves that decimal over, and my 4 times 10 just makes the bottom 40. So I get 98 over 40. Okay, let's think about how we can simplify this. So the number that comes to mind the fastest would probably be 2. So if I divide the top and bottom by 2, I get 9.8 divided by 2 is 2 goes into 9 4 times, and then into 18 9 times, and that's going to divide into 20. So 49 over 20. I will take that as an answer as well. Some of you like to convert it to a mixed fraction. I don't care. But let's say you do, then that's going to be 2 20s give you a 40, 9 left. So that's our mixed fraction. 2.45 is good enough. And improper fraction if you so wish to. Okay, so that is question B. Let's find the equivalent example for you to try. The equivalent example for you is going to be question F. So give you a moment to pause the video to try F. Okay, so let's do F together. It's a little bit easier, but since we have a square, we need to take the inverse operation, which is the square root. And of course, squaring the entire side of each part of this, both sides of the equation. Square root and the square functions cancel. I get x left by itself equals to the square root of 81. And if you want, you can think of as square root of 81 on the top over the square root of 4 on the bottom. What's the square root of 81? We know that is 9. Hopefully we know our multiplication tables. And the square root of 4 is going to be our 2. So 9 over 2, if you want it as a mixed number, you could. Then this would just be 2 times 4 and 1 over 2 as a mixed number. Or if you would like this as a decimal, this will be 4.5. I will take all of these as answers. Okay. Okay, last one, last pair, okay? C, let's do C. Ooh, C looks a little tricky, haha. Okay, so again, we're gonna need to isolate for the x, okay? We need to get x by itself. Now this is a little bit tricky because notice there is a negative sign, there's a minus sign in front of the x. There's in fact 2 ways you can solve this. I would suggest that if you are somebody who will forget their negative sign, then I'm going to show you this method. It's a little bit longer, but hopefully it will help you it will help those of you who will forget your negative sign. Okay? What I'll do is let me divide this little tiny space into half, and I'll do my best to make sure that I don't go over it. Okay, so I'm going to do this first method. This first method is for those of you who love to forget your negative signs. If you forget your negative signs, this is probably a little bit better. Okay, Now, this first method is the following. First of all, I have negative x. Who wants negative x? We don't like negative x. If you take a look at all the examples we did, it was all x is equal to blah, 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 blah. If we have a negative x, it's it's just not very nice. So, in fact, I'm going to add the x to both sides of the equation, because that way it's as if I've moved the x to the other side of the equation effectively. So take a look at how that happens. Plus x and minus x cancel out. So I'm going to be left with 3.5. Here, let me zoom in. Okay. I get 3.5 is equal to 1 plus x. And imagine I'm adding x to the whole side of the equation just like that. It looks a little bit better, right? So x is now positive. And now I just need to make sure I get the 1, move the 1 to the other side, or effectively getting rid of the 1. And anytime I have a 1 right over here on the edge, and there's nothing on the left side of it, well, maybe you're looking left side of it. Left side is it for you is over here, okay? If nothing on this side of it, then think of there being an invisible positive sign. There's an invisible positive sign in front of the 1 if there is no sign there. So that just means that I'm going to need to subtract this 1, just like that, okay, to get rid of it. And of course, I need to do it to both sides of the equation. So subtracting this 1 is going to get rid of it, just like that. Now, you might be thinking, whoa, x is on the other side now. It doesn't really matter which side x is. It's still the same thing. It's just, I just look at the scale from the other side or something, whatever. So now I have 3.5 minus 1, and that's going to give me 2.5. Aha! If you like x to be on the left side, then sure, you can rewrite it. X is equal to 2.5. So let's do a quick recap. Now, because I have minus x, we don't like minus x. It's just ugly. Those of you who love to forget your negative signs, use this method, move the x to the other side, then solve the rest of the equation. Those of you who don't care, or you're really, really vigilant with all of that stuff, I'm going to do the next of the solutions in purple or magenta. So if you're okay with, and of course you love to minimize the number of steps that you take, then of course you can do it this way, okay? So I'm going to leave the x on this side of the equation. I'm just going to be okay with it being negative. And again, I'm going to repeat myself. Imagine that I have a invisible positive sign in front of the 3.5. That happens for any number in the front of the equation. Imagine there's an invisible positive sign. So I need to move the 3.5 to the other side so that I isolate for x. So to do that, since there's that positive sign, I'm going to subtract 3.5 on both sides of the equation. And what that effectively does, don't forget the brackets, is I can get rid of this 3.5 on this side of the equation, and this is where some of you who love to forget your negative sign is going to forget your negative sign. I have to remember there is a negative in front of the x. I didn't get rid of it, so I get negative x is equal to 1 minus 3.5. What is that equal to? That gives me negative 2.5. And hey, look, if I have a negative on one side of the equation and a negative on the other side of the equation, I can just cancel them out just like that. And if you're yes, right? What that means is I've multiplied both sides of my equation by -1. That's effectively what I've done, okay? But simply, you got negative on this side of the equation, negative on the other side of the equation. You can just cancel out those negatives. So I get the same answer as what I just did before, okay? X is equal to 2.5. So whichever method you like better, then go with it. It really doesn't matter. But I've shown you the tools, okay? Now, hey, this is the time for you to try a very similar example. You're going to do D, okay? So you're going to be doing this guy over here. Good time to pause the video. Okay, time for me to go over it. I am going to do the same thing. I am going to go over this one in two ways. Yeah, I'm going to do it in two ways, okay? So the first way, which is similar to what I did before, is for those people who love to forget their negative signs. So because of that, I am going to move this x to the other side by adding an x to the other side of the equation, which then cancels out this negative x here, meaning I'm going to be left with just the 9 is equal to 1 plus x, just like that, okay? And now to isolate for the x, I need to subtract the 1 on both sides of the equation since I have an invisible positive sign in front of my 1, okay? So that gets rid of that. 9 minus 1 is just equal to 8. 8 is equal to x, and if you like to read it in a linear fashion, you can rewrite it like that, okay? That's the first method. The second method basically is you don't really care where the x is, if x is positive or negative. So you kind of just deal with the 9 first. You actually try to isolate for the x. And I'm going to move the 9 by subtracting it on both sides of the equation. Don't forget the brackets. Okay, so this 9 cancels out with that 9. I get negative x is equal to 1 minus 9. That is negative 8. Okay, I have a negative on both sides of the equation. Again, I can then cancel the negatives out. I get x is equal to 8. All right, very similar deal. Wow, we did it. Those are the tough problems. And if you've gone through it, you've done it, great job. Guess what? You're doing a fantastic job. If you're keeping up with these videos, thumbs up to you. All right, thank you for watching. Good luck with your examples. Fan Mama Physics signing out.